Hi, my name is Jeremiah. I'm a junior in electrical engineering and I'm currently in ECE 311, 331, and 341. Okay, so the circuit we're talking about in this KI is a two-stage system. The first stage takes an AC input, VIN, and this first stage is a rectifier circuit composed of 4 diodes. And it's set up in a way where the output of the circuit is essentially the absolute value of the input. So the output voltage from this portion of the circuit we're going to call Vrect. So I'll just outline this in green here. So this is the first stage of the circuit where Vout is essentially, or Vrect more specifically, is essentially the absolute value of Vn. So the second stage of the circuit is an RC circuit, which is composed of these 2 diodes as well as a capacitor. And the output from this circuit we're calling Vout. So we've got R1, R2, and C. And so that is this portion of the circuit. And essentially what this is doing is a smoothing operation, which is very similar to integration. So I'll just say Vout is the integral from minus infinity to the current time of Vrect. Okay, so the circuit that we're talking about has components from each of the 3 ECE courses, 311, 331, and 341. So the first one I'll talk about, 311. The main concepts that we've really been talking about in this course so far are linearity and time invariance. So I'll talk about that for each portion of the circuit. So for the rectifier, this circuit is time invariant, but it is not linear, and we know that because it takes a sinusoidal input with a DC level of 0 volts. It's centered around 0, but it gives an output that has some DC level. So basically we can say that it is scaling the 0 DC level of the input to a non-zero factor. So you can't do that in a linear system. It's not a linear operation because there's no constant coefficient that you can multiply 0 by to get a non-zero value. So for the RC network, we can say that this is time invariant as long as there's no initial charge on the capacitor. So that's just an important note. If the capacitor is initially charged, then it would not be time invariant. And it's also linear. That's because each component, the resistors and the capacitor, are all linear components. So overall, we have a nonlinear system because the rectifier is nonlinear, but we do also have an overall time invariant system because each of the individual subsystems are time invariant, so it makes a time invariant system overall. Okay, so for the 331 portion of this circuit, the main thing we've been talking about in that course is diodes and their various types of behaviors. So one important thing about the diode is the threshold voltage, so I'll talk about that for a second. So if we look at just the diode portion of this circuit, I'll draw the input once again, sine wave. So the output of this circuit, if the threshold voltage were 0 on the diode, would look something like this. So as soon as we start getting a voltage on the inputs, 2 of the diodes would turn on and allow current to flow. And then as soon as the input becomes negative, the other two diodes would turn on, and overall we would get an output that is the exact absolute value of the input. With real diodes, there is some threshold voltage before they're allowed to turn on. So what we actually get for the output is something like this. There's some period of time, T0, where the diodes all remain off, and then they're allowed to turn on, and our output follows the input, but there is an offset of 2 times the threshold, and that's because that's the drop across the 2 diodes that are on. And this time right here can be described as when the input actually reaches 2 VD on, and then after that point the diodes become forward biased and they turn on. And then the same thing happens for -2 VD on for the other 2 diodes in the circuit. So after that time, we'll see the same behavior, and this is just repeated over and over again for the input. So lastly, we want to talk about the implications of electromagnetics on this circuit. And I won't go super in-depth here, but essentially what we want to look at is how the diode is a nonlinear circuit element due to its electromagnetic properties. So if we draw a p-n junction, basically this is going to have a charge density in the volume on each side, and if we draw along the x-axis here, due to that imbalance of charge density, if we draw the electric field, it's going to look something like that. And then if we integrate that over x to get the electric field, we are going to end up with something that is shaped like this. And that essentially describes how there is a potential hill in the diode, which is why it's much more difficult for current to flow in one direction than another, because if it's going to flow this way, it has to gain a lot of potential energy to overcome that hill.